This livestream series is sponsored by Slice Engineering and the Mosquito Magnum Plus hot end. Push absurd amounts of filament while maintaining the structural integrity of the Mosquito design. The Mosquito Magnum Plus can be configured with up to 100 watts of heating power, redundant 500 degrees Celsius rated thermistors, and air or water cooling. I'll be using the Magnum Plus for this build, and you can find the links in the description below. Also, Do-It 3D, the Voron printed forward team, and Lineo were kind enough to provide some of their high quality parts for this build free of charge. I've purchased the rest of the parts on the regular, like the Formbot kit, upgrades from Firmware Labs, and little bits here and there. You can find links for everything in the description below. Now, let's get started with the build. Welcome everyone, and hello to the last final finished stream of the Voron 2.4 build. Today we are gonna print. We're gonna print something with this machine. I have done a couple things between 2 days ago and today. When we were at the point where the firmware was configured and the wiring was like mostly cleaned up and all. But yeah, let me just walk you through what I did since we saw each other last. So, toolhead. That fan doesn't sound particularly good, but toolhead. It was still missing the PTFE between the extruder and the hot end, and that is now inserted. I did not use the horrible quality. Where is it? The horrible quality PTFE that was included with the which end? Yeah, I guess that end shows it. The horrible quality PTFE that was included with the Formbot kit, like you can see how much off center that was. I did not use that. I used the Mi3D PTFE. So that's in there. I did use this to install the spool mount, which is now living on the back of the printer. You can see that back here. This camera keeps dropping because it's too heavy for its mount, but anyways. That's the spool mount back here, and it has like this little PTFE insert where the spool rides on. So that's nice and smooth with just the right amount of friction. Yep. Then what else did I do? Yes, so I finished all the firmware configuration, and that was a couple of things. So last time we were kind of stuck at the point where it was like, okay, you're gonna have to set the individual Z-axis motors up in a way where it's gonna self-level, because by default, I mean, I can move the Z-axis up and down, and that's gonna really quickly get things out of tram, out of square, out of everything. However, due to the magic of doing stuff when I'm not in a live stream, and due to the magic of Do-It, nope, that's the one I want to press. I have set this up in a way where is it? I believe it's this. Yeah, so this basically sets where the belts attach to the XY gantry, and then in the, so that's just positions X -60 and then Y -6 is, for example, this front corner where the belt attaches relative to the nozzle when it's at the 0, 0 position. There you go. And then what we can do is in bed.g, we can basically tell it, okay, probe at the front left corner, and then, or go to the front left corner, then probe at the front left corner, probe at the rear right corner, and so on and so on. And with the S4 at the very end, it actually real-time compensates, or it corrects. It doesn't really compensate, but it corrects any sort of skew, any sort of unlevelness you might have in your Z-axis. So let's try that right now. Theoretically, it should work. I've had it skip some steps on the Z-axis a couple of times, but I did crank up the current since. So, excuse me. So we are at following axes are not homed X, Y, Z. I'm just going to hit home all, and theoretically that should do an X home, X, Y home, going to the rear corner. Then move to the center, do a Z probe, and then do each of the corners and do the correction. So there we go. That actually got stuck on the rear drag chain. That's something I'm still going to need to fix. That got stuck with the wires that are still sticking out. But that's now the compensation cycle for the Z-axis, and right there you could see it's slightly moved each of the Z-axis belts. And these are the heights that were measured. So front left is basically at 0, rear left was 4.7 millimeters too far up. Then back right was okay again, and then front right was too low. And that now theoretically should have the XY gantry perfectly square or perfectly trammed relative to the bed. Give me 1 second, I'm gonna need to turn off my heater because I'm starting to sweat. There we go. At least turn that down a bit. I'm excited about today's first print basically. So let me home this again. I did slow down the Z-axis probe. What you're seeing right now, that got slowed down quite a bit because I'm not sure how quickly that sensor actually registers. And I did note that the nozzle was slamming into the bed. So yeah, this is the only slow part in this entire thing. That's the front compensation, rear compensation, and so on. And now we have a trammed printer. Yeah, I mean that's what you get when you build a Voron. Also, what else did I do? I did do the heater calibration or PID tuning for the heater. The way that Do-It handles it, I believe, is it's not just tuning the PID loop. It is also creating a model for what it should expect the heater to do. So those errors that we were seeing last time with heating failed because it was not heating up fast enough. That was based on assumptions that Do-It was making about the heater. And because we hadn't calibrated this specific heater, it was assuming a faster hot end with less thermal mass. And obviously, with that chonker of a hot end in there, that's all copper. So that takes a while to heat up. It only has a single heater installed at this moment. It does have two, well, it only has one heater hooked up. It has two heaters installed. But I didn't want to, you know, mess up the nice, neat wiring that Lineo provided, the red crimped wiring that we have. This was too nice, so I only have one of them powered right now. In RapRap Firmware 3.4, which is like in pre-beta state right now, you will be able to do two heaters on the same hot end or on the same tool from two different outputs. So my wiring loom right now, it has two heaters in the hot end has two heaters in there. It has two connectors going to two pairs of wires all the way down to the electronics, and then there are two connectors for those two heaters. So I could control them separately. Maybe I'll just sort of a wire adapter or something at some point. But that's heating. That's working. What else do we have? Spool mount is attached. Yeah, I did have some issues with the Do-It boards. So first of all, I was wondering, like, hey, the extruder motor is the only one that is attached to the 3HC expansion board. So this guy right here, smaller motor, this is the only one that's connected to the 3HC board. And I couldn't get it to turn. It was buzzing as if one of the phases was not connected. I tried switching the stepper channels around. I plugged the XY motor in there, and it was always the 3HC board that was not working for me. Thankfully, the only thing that I had to do was to upgrade the firmware. The main board was running 3.2.2, and the 3HC expansion board was running 3.1. And all you have to do is you upload the firmware package, which is a zip that you get. So basically, upload system files, Do-It 2 and 3 firmware. You can download that off of GitHub, and that automatically updates everything in your system, including all the expansion boards, the main boards, everything that's connected to the Do-It. So I did that, then it was fine. I could still not reverse the direction of the extruder motor, so it was still going the wrong way. And even when I changed it in the config, where is it? Up here, so physical drive, that E 1.0, that's my extruder drive, so 1.0 right here. S1, S0, that should theoretically reverse which direction that motor is going, but whatever I put in there, S1, S0, it just did not reverse the extruder. So I just physically flipped the switch. The connectors don't like that I had to cut a couple things off, but it's in there now, it's fine. Whew. What else? Paul's asking, Z offset is calibrated. Yes, Z offset is calibrated. You can actually see that in here somewhere. There it is. 0.4, pretty much exactly the nozzle hitting the bed. I guess there's a nicer way to do this, but I just put it in the config. I guess you can also do the G31, set it temporarily, and then save it to config override.g with the typical, what is it, M501? 500? I can never remember which one it is. But that's configured. It does extrude. I did do the first extrusion line yesterday. I posted that on Twitter. So all that is left to do now is to set up a slicer and to get printing. All the mechanics work, the hot end works, the tuning is correct, the Z offset is correct. There's not much left to do. So let's actually do that. So we are going to use Prusa Slicer. Supposedly there are a couple of profiles available for this one already. My bed moved forward? No, Martin, that did not move at all. There are supposedly a couple of profiles for Prusa Slicer, Cura, Simplify already, but since, I didn't exactly build this to spec with the Mosquito Magnum Plus, the Do-It, and a couple of things. Well, I don't have the nozzle probe for one, the tool length sensor. I do not have that installed at this point. So I guess if this sensor gets warm, it might change the trigger point. But with a 1mm nozzle, how much is that gonna matter? Yeah, all that's left to do, set up the slicer profile. I'm gonna go from scratch. If I can find the config wizard down here. Remove presets. Yep. So let's just quickly set this up from scratch. And the default, I'm not going to steal the Prusa profile as I've shown in the video before. I'm going to set it up from scratch because this thing is so far off from this thing is so far off from what a typical printer can do that, I might as well just, go full custom. 300, XY0, that's correct. Nozzle diameter 1. Yes, I also did calibrate the steps per millimeter for the extruder. Surprisingly, the default that is in Do-It firmware was 0.1% off. So I was extruding 100 millimeters and I got 100.1 millimeters out of this extruder. So I don't know if that is just happy coincidence or if the gearing is just the standard setup that is set up in RepRap firmware, but worked beautifully. So extrusion temperature, well, we're going to use a custom profile anyways. I do have PETG loaded up at this time because I don't think we're going to be able to cool PLA fast enough. And I think these are not, well, some of them might be available for custom printers. Are there? Oh, I have Prusa Mint PETG copy. So that's actually the one that I copied off of the Mark III. They were saying it's basically a Bondtech BMG, so I guess that is what this setup is for in RepRap firmware's config. We're gonna be printing a thick bench, yeah. So a couple questions from chat. There's some Prusa Slicer profiles. Yeah, Nero, I saw that. Thank you. How much was the build? 1,500 euros, roughly. You could build it cheaper. You could build it more expensively. P3D Prince is asking, how is the chat screen? So I have two screens here, actually. If I, pulling out my phone and exposing private details again. Well, I'll keep this in flight mode. So basically, you can see that's the chat screen right there, and that is the let's do it like this. Mirror on the wall. So there is the chat screen, and back there, that's the camera you're out of right now. Back there is the broken Streamlabs screen. So there's chat. That one's fine. I did order a new one. $107. These things cost nothing these days. And it should be here tomorrow. Not in time for the stream, but anyways. Let's get this profile set up. 0.3. Yeah. Dustboat, I can see you in chat, yes. 0.3 sounds about right. First layer height, 0.35. 3 parameters, let's stick with 2 because these are thick anyways. 3 layers, let's go 4. What are we even going to print? I guess we're going to start with a 2x scale benchy. Ensure vertical, yeah. Thin walls, bridging, yes. Seam position, let's just stick with, let's stick with nearest then, yeah. Infill. What is an efficient infill pattern? I guess triangles? Or cubic? Cubic is all straight lines, no accelerations, no nothing. Cubic is going to allow the printer to stay up at speed for the most time. Monotonic, that sounds right. So that is the newish pattern that only moves the nozzle in one direction. That's fine. Hiring, nope. No combine infill. That's all fine. Skirt and brim. 1 skirt loop, fine. Support material, nope. Speed. Speed with a 1mm nozzle. Yeah. So, Daniel, this is the extruder PETG matte. So this is white PETG from extruder. I chose it for the color mostly because white is going to be nicely visible against the gold bit. Speeds. I don't know how legible this is for you guys. Probably not very, unless you're watching on a desktop. Perimeters 60. Sounds a bit slow. So one thing to note is where's our flow ratio? That's in filament, right? Actually, let's save this as a Voron copy. One thing to note, there it is, maximum volumetric speed, 8 cubic millimeters a second. 8 cubic millimeters a second is not a lot. So the Mosquito Magnum Plus supposedly does about 90 cubic millimeters a second. That's over 1 gram of filament per second if you keep the hot and fed at full speed, with both heaters. With one heater, they're saying it's going to do about 60. So we're gonna plonk some speeds in, but I'm gonna keep the volumetric speed limit in here at 60, and then filament speed 10 millimeters. And then we're going to check the preview and see ABS at 300. Okay, so maybe let's bump this down to 50. And then we're going to check the preview and see like how much we're actually extruding, what volumetric flow rate we're actually getting. So yeah, let's get this started at 100. Small perimeters, 40-ish. External perimeters, let me stick it with like 70% speed out of the standard perimeter. Infill, hundo. Solid infill, hundo. Top solid infill, hundo. Support material we don't care about because we're not using it. Bridges, I have no idea. It might be good to go a bit slower here. Travel, 130. Are you kidding me? 800. First layer speed. Okay, so that might be a limit for how much we can actually extrude per second. Let's stick with 30 for this because I do want a bit of bed adhesion, and it's going to speed up after that. Acceleration control we're going to leave off, and that is going to just use the firmware maximums, the firmware defaults. Multiple extruders, don't care about it because we only have one. Advanced. Default extrusion width, 1.12. Sounds about right. First, I love this. Like, every time we touch one of these layers, it's like, yo, are you sure? Are you sure? Did you mean 1. No, I did not mean 1.12%. First layer, let's bump this up to 1.4. Just to squeeze it down a bit more. So the XY size compensation, elephant foot, we're gonna... Oh, that, no, censored. No, I'm sure this is correct. I know what I'm doing. Prusa Slicer needs like a setup box, so it's like, I know what I'm doing. Like, hey, don't bother me with... I don't think that's in here. Don't bother me with you thinking you know more than I do about my machine. So that's good. Output options, we don't need that. Notes, we don't need that. Dependencies, all good. So, Voron 300. Save. Nero, I should try Super Slicer. Well, I'm not going to try it now. I might try it at some point in the future, but like right now, I would rather use what I'm comfortable with. There are already so many things that can go wrong with a completely scratch-built printer that I'm not familiar with. So I would at least have, I would at least want to have some parts that I'm familiar with. So we're sticking with Prusa Slicer for now. Prusa Slicer. 1.75 extrusion multiplier is correct. That's correct. That doesn't matter. 240 on the nozzle. Yeah. 240. We are going to be pushing a bit of material, and I think for the heated bed we don't need that much temperature. Actually, let me preheat the bed because that is going to take a while to stabilize and to heat up. Let's just go to 90. Just to make sure everything is already soaked and we're not just reading the temperature off of the thermistor down there, and then, you know, the top would still be cool. So let's just get that heated up. Cooling. So basically we're going to have to stick to full cooling speed. With the amount of filament we're pushing out, I don't think we can get away with cooling any less than this. And PTG kind of doesn't care about that all that much. Disable for the first, like, one layer? Enable fan time is, yeah, I mean, this is always on anyways. And then slow down at 20, yeah. Sounds about right. PTG, non-soluble, 50, that's correct. Tool change, we don't care. Retraction length, well, that's going to be something we're going to have to figure out, but with a 1mm nozzle, I don't think retraction is going to do much. Z-hop, on the other hand, we can actually bump up because our Z-axis is super snappy. M900. Nah, don't need this. No. This mouse is garbage. Keeps jumping around. So start and NG codes. I guess NG code we just do home XY. And turn everything off. 250, that's good. One extruder, wrap up firmware. Supports remaining time? I guess we can do that. That's all good. Custom G code. So G28 is actually all the G28. And because our G28 has that move to this center position already built in, we don't need the extra line where it moves up just a bit. I do want to keep the probe as cool as possible. Don't want to soak it near the bed when I don't need to. Turn of temperature, for some reason it is still missing the line for turn off the heated bed, which is M140. Home X and Y, and disable the motors. Yeah, we're gonna rehome anyways after the or before every print. So any of the advanced G-codes we don't really need. Oh, what are you? Color change, pause print. Okay. Extruder 1 millimeter diameter. Min max, that's good. Retraction by default is 2, but that gets overwritten by the filament. Retraction 40. I don't know what this extruder is capable of. We're just gonna try it. And that should be the profile pretty much completed. Sander, yes, we are doing a quad gantry level in the print starts. That is done in G28. That is all included. Cool. All right. That should be the quad level gantry. It's in G20. I added that to G28. Let me just demonstrate again for all you doubters. So if I literally send it a G28, this is what we're getting. So we're doing the regular home. We're doing the home probe up front, and then it's going to do the full quad gantry level. So what are we printing onto? We are printing onto the energetic, I guess this is the energetic brand PEI. And, oh, heater 0 fault. Interesting. Oh no. Oh no, I did not tune the bed. Ha. Can we... Does anyone know if there's a way to turn off the heater fault monitoring? Because I did tune the hot end. The hot end is fine. The hot end works perfectly. But what about the bed? I guess if I turn this off and I turn it back on, then it might not trigger. PTG on PI, supposedly it works. We can, I guess to be safe, we can add a layer of glue stick onto the center portion where we're going to be printing onto. Nero, yeah, wrapper from a PID tune takes forever. I'm not going to do the PID tune right now. Glue stick, where is my glue stick stash? We're already back at fault. Yeah, it was too slow, I know. Glue stick! I had some here. Fantastic. Reset fault. And let's get you heated up again. So this is a removable sheet. So it's reading 40 degrees, but this is 22 at best. Okay, turn you off again and M307 H0B1S 1.0. Okay, I will give that a try. Okay, let's see. Let me see what this... So, let me first of all verify what chat is trying to say here. So, we go into System. We go to Config and we check the... So, that's the config line for the hot end. And that is exactly what Mako has posted. So that can't be it because that's already what's being set here. Actually, let's look up what M307 does. Whether we have some way of turning off the safeties. Heating rate. Well, I guess if we do heating rate, then that should be the expected heating rate, right? So let's see if we do that. And if we do R1, roughly, maybe that's going to allow us to get a bit of bit more leeway on our bed heaters. So, glue stick, these Chorus glue sticks that Prusa includes are always smelling super weird. We don't have a prime line, right? So it's only going to be the center of the bed. Alright. No glue stick on texture, too late. You guys were scaring me into putting some of that stuff on. I mean, it's gonna stick to the textured stuff anyways, right? It's not gonna hurt. PTG is gonna stick to it. And if anything goes wrong, it's going to protect the textured PI sheet. Prusa, as far as I know, were the first ones doing these textured sheets. They do say that the textured one is fine for PTG, but I don't really want to risk it with a bed that I don't know how well it is made and how it exactly is made. So, don't print PTG. Well, Nero, we can't all print ABS exclusively, even though you'd like to. But we're gonna try some more accessible stuff. So I'm gonna grab my FLIR camera real quick, and we can check how hot this gets because the firmware is reporting it's at 70 degrees, but this is not 70 degrees by any margin. Oh yeah, I did update these graphics, by the way. So that's actually a live image. How are you liking that? Be right back. Same old graphics, right? And the best thing is, I was like, for probably ever since I was thinking about, hey, you could maybe do something like that where it's a live background behind that animated graphic. I was like, wow, how can I blur that out? How can I make that blurry? Like, OBS doesn't have a filter to blur a camera feed. I don't know how we would do it with custom shaders. And then eventually I just realized, well, I can just manually defocus the lens. Like this is one of those microscope cameras that has the C-mount lens on it, and I can just, it's a manual focus lens. I can just pull it out of focus. So that's that. Like sometimes the easiest solutions are the best. So here is our live view of what the bed is looking like. And yeah, I mean, I guess emissivity is a thing with these beds. These are slightly reflective, so they're going to read a bit too low, which is why the glue stick in the center is actually reading higher. And it is reading 59 degrees roughly, so 60 degrees, while the firmware is reading 70. So there is an offset. What we can also see is there is a bit of a, come on, calibrate. The corners are a bit cooler. So the corner right here is at 47, and then the center is at 52. So even though this is a rather large slab of aluminum, there is still a drop off because the heated bed that they included, or that form bar included with this, was too small. So there is a rim around the edge where there is no heating happening. However, it might also just be that this needs to soak with heat first before it's, so it will need to heat. Let me restart over again. It will need to fully soak with heat until every bit is the same heat. Incendium, yes, that camera is a dedicated camera into a dedicated HDMI input. Dedicated just for producing a blurry image. I know, it was just the easiest solution. So, let's get this bed heated up. Well, let's let it heat up. Oh, it's bang bang. I can see the LED down here. What is this? This is a Fleur 1 Pro. Fleur 1's cool too, but this is basically a smartphone attachment. It has a USB-C if it focuses. USB-C connector plugs into your phone, and it has a come on, no, yes, has a lens for like your actual RGB image, and then it has the thermal lens, so it actually can give you an overlay of like what the world it's seeing actually looks like and what it looks like in deep IR. Pretty cool. Fleur 1 Pro, $400. There are cheaper alternatives, but this one's good. So, slicing. Slicing. What's the print? What are we gonna print? What are we gonna print? Swole Pikachu. Ah, that was the Tree Frog or Benchy. I guess that's the only two real options we have here. Maybe I have some more STL stuff on this one. ST. Do I have? Oh yeah, I do have a folder called STL with more stuff in it. Is that shit the box generating the previews? I think so. Benchy. And we're not gonna do Voron calibration cube. I'm not gonna print the calibration cube. Forget about it. Benchy has a cube built in. Benchy. Everyone wants to see a Benchy. Okay, I hear you. Tree Frog is done. And how long are you gonna take? 37 minutes. I think we should actually scale this up just a bit. With the we can always we can always increase the speed on the printer. So while it's printing, we can crank up the speed through the web interface like you can on any printer. There's going to be something just made a noise in the printer. Probably the acrylic expanding. Where is it? Status. Speed factor. We have a speed factor slide, and when we push to 150, yeah, it's going to reset to the center, and it's going to give us 150 on top of that. So we can always bump that up. Right now, we're at 100 millimeters a second, which is, actually, let's have a look at this. Feature type, volumetric flow rate. Wow, that's unimpressive. Look at this. So, like the transition between green and blue is 10 cubic millimeters a second. So this isn't even enough to like exhaust the flow rate you'd get out of a V6. So yeah, minimum layer time is set to 20 seconds right now. Though if we speed up the print, that minimum layer time is also going to get sped up accordingly. So down here where it's probably all minimum layer time. Do we get a layer time? No, we don't get a layer time indicator, but how many layers do we have? We have 160 layers. So let's see what the average layer time is. So 37 times 60 divided by 160. 13 seconds? No. 13-second layer time? Nah, that can't. That's faster than the minimum layer time. Hold on. 37 minutes, 60 seconds each, and we have 100. Oh, okay. Okay, so the minimum, the layer time is actually faster than what we set for the minimum, because we have also set a minimum print speed of 15 millimeters a second, which is quite a bit of flow actually. So speed view drop down, speed. Good, where do we get layer times now? I would say let's just stick with this. And we can... oh yeah, we do need to scale it up. So if the printer keeps making creaking noises. So let's do 200 and see how much longer this takes. I don't think this is going to take that much longer. 1 hour 58, that's too long. Let's do 150. Whoops. Let's do 150. Because if stuff goes wrong, I want to be able to have a second go at it. I want to have a second chance of getting this right. So 1 hour 15 minutes. Let's check flow rate. Yeah, okay, now we're in the 20s. And of course we can always speed this up. Now this is not going to be a 6-minute benchy on the first try of this brand new build printer Heart K or even Batterman. Like, no, that's stupid. You don't do a 5-minute benchy on a printer you've never used, okay? So we're going to take it reasonably slow. I mean, this is still much, much faster than what any other regular printer would be able to do. What is about blank? What are you? Upload and start, I guess? Upload and start. Settings. No, I refuse. You're not the boss of me. You can't tell me how fast I'm supposed to be printing my benchies. That is my choice and my choice alone, okay? Warning, M73 is not supported. Okay, I guess the print time progress then is not supported. Anyway, we're printing. So, okay. Bed is at temperature, bed is at 80 degrees, supposedly. The hot end currently is heating up. And everything's going to move to the center there, and then wait for all the little bits, all the heaty bits heating up in the printer itself. Andre asking, can you share that Prusa size profile? So once everything is done, and I know it works, I can share that as a basis, but like this is just calibrated or set up on gut feel. Like there's no tuning to this yet. This is literally just, you know, what I felt was okay. Yeah. So take a look at the filament spool. Yeah, I know that's falling off. So typically, what you have in a Voron is of course a full enclosure, but you also have an air filter and filament outlet in the back right here. So you would typically have a full PTFE guide from your hot end going back here and kind of restraining that and making sure that the filament is not bouncing around inside the machine. But since this is a bare minimum build so far, that sort of stuff, did you hear that? More creaking. Since this is a bare minimum build so far, that's going to get added on later, but I think it is a very reasonable addition because that's just going to keep any forces from pulling on your tool head, because now those forces pull on the frame instead, and there it's like, there it doesn't matter at all. Have you printed anything yet? No, we are just at that printing stage. We are heating up the hot end. The bed is at temperature. We are getting there. I've just started the very first print on this. So let's see what this bed looks like. Hello? So 70 in the center roughly, and then 60 at the corner still. So this, I guess, still needs a bit more time to heat up. So yeah, it's fine in the center. It's gonna stick. It's got glue stick on there. Why does it have glue stick on there? Because chat scared me into putting glue stick on it because they said that shouldn't print PTG onto a... Did I even have this filament loaded fully? Oh yeah, I did. I shouldn't print PTG onto smooth PEI, and off we are! That Z-hop is insane. Also very, very quiet otherwise. Like, just, all you hear is someone just banging the table, but otherwise... Yeah, also, this filament probably is a tiny bit wet. Okay, part cooling fan engaged. It's a bit much material in it. So I'm hoping once we make it, through those first couple layers. Oh yeah, the extruder is already skipping. That is way too much material in there. I did calibrate the extruder, but like I said, I've never printed with it. But hey, Mosquito, it's robust. Should be alright. Do we have a... Yeah, we have an extrusion multiplier factor. I'm just going to bump that down to 30 real quick. Just to give it a quick chance of recovering. 30. And then I guess one layer in we can reset that. And... nope. That is making all the wrong noises. That is way too much material. I guess that moves up. Yeah. That is way too much material in the first couple of layers. I'm gonna need to check that. Extruder fan PWM is still too low. No, it's fine. Extruder motor should be around 0.5. It's more than that. I think I put it to 800. This motor supposedly does 1 amp. But yeah, that is maximum over extrusion. So if I grab that with a grabby tool, where did those go? Where did my grabby tools go? Come on. There they are. So if I pull that off of the bed, come on. Okay, glue stick is sticking well, so we're not going to have any issues with bed adhesion. That's good to know. That is slightly over extruded. Just a bit. Just a bit. We have a flex plate. We do have a flex plate. I forgot about that. Though with thin prints like this, the flex plate's not going to do all that much. Because the print is just going to bend along with it. So yeah. Thanks for the 2, Kyle. This is a sign you need to print the Voron cube. No, I'm not going to print calibration cubes. Can't make me. So my guess right now is just the first layer was squished down too much, because this could either be... Why am I hiding behind the printer? This could either be the first layer just being too low and accumulating, or actually way too much extrusion. So to fix that... also, yeah, of course, the glue stick did add a bit. To fix that, to check that, we can do a quick extrusion volume test. Check volumetric extrusion. Well, thanks for the $2 tip, Landon, but volumetric extrusion, I don't think just enabling that is going to change or fix anything. I am going to check the extrusion volume, though. So I'm going to mark this at 150. Right up here. So 150 is going to get a little blue mark. And then we are going to extrude 100 millimeters, and we're going to check whether we still have 50 millimeters left. That line width is too much for the first layer? No, it's not. So, let me see, heating up the hot end right now. Getting that up to temp. And I guess we can keep the beta temperature as well. Minimum layer height for 1mm is 0.5? Nah, you can do 0.3. Totally fine. I mean, you can do 0.05 with a 0.4mm nozzle, so that is factor of 8. Yeah, factor of 8. So factor of 8 for this one would be 0.125. So it's fine. This layer height is fine. 180, that's good enough to extrude. We've got 100, we're going to do 15 millimeters a second, which is still very fast. And we're just going to let this feed in. The dot is right there. We're just going to let this feed in 100 millimeters. Oh, skipping, that's not good. Guess the hot end is still a bit too cool. Or maybe we need to go a bit slower. Let's do 150 again. So that was at 100 degrees or something. Why are you in heater fault again? How did we get rid of this? Oh, we added the R1, right. Come on. That's still in here, so that should allow us to actually heat the bed to temperature. 240. Let's try this a bit more slowly then. Ha! I forgot how slowly that 1mm thick extrusion cools off. Yeah, as you can see, that's a bit bubbly, bit warm. Filament is tangled on the spool holder. Yeah, I know. Are we in? We're in. So that should theoretically be just about 5 centimeters. It's a bit less than that, so yeah, we're like 0.2% over, which is fine, really. So let's try. Are you still the same? You were still the error from a second ago. Let's try this then. We're gonna do the home. We're gonna print everything. Where's my files? Jobs. We're gonna print the same file again, but I'm gonna baby step up on the very first layer. I'm just gonna bump up the first layer height or the first layer offset, and yeah, relative versus absolute extrusion doesn't matter for extrusion amounts. It matters if you change your steps per millimeter for the extrusion mid per. I don't like those noises mid print, but doesn't really do much there. Right. So I shall restart this print. Yeah, I do need to fix that wiring back there because it is bumping. It is bumping into the drag chain. I think Paul or someone pointed that out a couple streams ago. What's the nozzle size? 1 millimeter. And then basically, we can just jump in here and go boop, boop, boop. And that should push it up by, yep, 0.15. We are 0.4 up now, so I guess the first layer would be slightly... I might have also messed up the first layer calibration, or the nozzle offset calibration, or also plausible, with the sensor getting hot, getting heated from the heated bed, it might just have changed its trigger point, because I've only tested this cold so far, so yeah. Also, that filament is looking wet AF. You again are looking way over extruded. Why is that? That is way over extruding. Just checking like roughly how much filament is pulling in, but I mean that's hard to judge. Yeah, I've dumped down the extrusion filament, the extrusion factor to 2/3. Oh, you can't see that. Sorry. Maybe if I do that, extrusion factor down to 2/3. So at the very least, that should help it recover. But if this keeps over extruding that much, like, I don't think I'm gonna be able to use this slightly too wet filament. So it is looking a lot better. I can also grab some ABS. What temp are we at? 240. But I do not know like how hot / cold the Magnum Plus's thermistor is reading. Because thermistors can have quite a bit of offset just from one to the other. You know, one hot end, same setup, same everything, just, you know, from one unit to the next, between the thermistor itself and the components on your main board. You can have quite a bit of offset, so yeah. Yeah, this is almost looking foamy at this point. Nah, I don't think this is going anywhere. Like, extrusion amount looks better now, but... Nah, we can do better than that. We can do better than that. So let's try. I'm just gonna keep this. I'm just gonna let this print in the background here. We're gonna try some Prushament ASA Natural. So this is 250 to 270 degrees is recommended, and heated bed 100 to 120. This is original in the box, never before opened, freshly sealed. These do have a zippy bag in them. So if you actually don't cut this open, like right through the middle as I used to do, these actually have a zipper bag that you can reuse. So that's good. So this is cream white. This is a nice color too. So this is fresh out of the bag, never before used. let's just set this up real quick. So 260 is the recommended one. Check printer settings tab and Crucialize. I don't think there's anything there that we need to change. 260, so the bed is reading a bit of an offset, so let's do 100 on the bed, and that should stick down, especially with the glue stick. And let me save you as Cruciament. Yeah. ASA, Voron. 260, 260, 100. We can live adjust the temperature if it's too cool. Cooling, I guess we can leave as is. Overrides. Section length, I don't know. But that should be all we need for the ASA profile. I'm going to leave cooling on for this one. I'm going to leave cooling on. I'm hiding between behind the printer the entire time. I'm going to leave cooling on because I think I should. Especially once we, well... Yeah, I'm going to leave it on. Especially once we bump the speeds, then... Yeah, it might get ugly. But we should be able to slowly get the... Or we should be able to get the minimum layer time down. Let's at least get this down to 15.
Hi Tom, do you have tips on printing overhangs with PLA in a room with 30 degrees Celsius temperature rooftop apartment south/west side zone?
Yeah, Christoph, that's a tough one. Thank you for the 10. How do you get good overhangs in a hot room with PLA? For the most part, unfortunately, you don't. You can't. You can't really beat physics. But oh, that's nice. Automatically moves away. You can't really beat physics. But if you want to print PLA in a hot room, lower your print temperature. I think that is one of the biggest factors. I mean, we used to print PLA at like 185, so that could be a start. You don't need to do PLA at 210. Otherwise, crank up those fans, go slow, the usual. Okay, let's get some of this ASA loaded up. So there is our sad little benchy. That is sticking down very well. Let me show you a close-up of that. Should I show you a close-up of that? Oh god. Oh god, here it is. Yeah. Wow. Wet PETG, everyone. Don't use wet PETG. Nah, not pretty. You're still at temperature, okay. Hundo to 50. So we do have unload. We do have load and unload somewhere, right? I'm just gonna retract. And that should work the same. Retract this out. Are you sure the filament didn't drag on the frame? It might have, but like there shouldn't be. Oh, that's interesting. That shouldn't be a difference, or shouldn't make a difference because the tool head should just pull it along. It shouldn't cause those issues that we were seeing as far as like print quality goes. I can never find the start with these. Yeah, also the spool mount, not my favorite at this point, but well. I guess I could move the spool mount to over here and then we'd have, nah. Not sure where I could move that. Look at that juicy white stuff flowing out. That's creamy white, right? Also, maybe we should give this nozzle a quick wipe down, because that is looking mighty fuzzy at this point. Ah, that smell. Yeah, ASA supposedly doesn't smell, but it does. Doesn't smell as much, I guess, to be accurate. I wish that hardened had a sock. It doesn't. Did the small PTFE piece get put into the toolhead cartridge? Toolhead cartridge. There are a couple openings in the bottom and not seeing anything there. All right. G-code. G-code. Upload. We've got the Voron ASA. Oh, I guess it could have disabled M37, or we're going to get these pop-ups the entire time. Somebody wanted to see printer settings, but printer settings, like, there is really not that much to see. There's no extrusion multiplier set for sure. Or is there for the filament? No, 1. So 1 is going to be ever so slightly high, because by default printers do like, or a lot of printers are set up. Failed to upload? Why? CRC is different? What? Let's try again. Yeah, so a lot of printers are set up to be less than 100% extrusion multiplier. Maybe we can try 95 as a start here, because this hardened theoretically should be calibrated for exactly, actually slightly over 100% of the volume extruded. So, but let's just give this a print. Keeps getting caught back there. That noise isn't nice. Is the nozzle actually 1mm in diameter? Yes, it is. What is up with you? Did some... What are we getting? Ah! We had this loose connector getting caught. With the toolhead dancing around. Not reaching the click, yeah. Just needed a bit of convincing. So, we are currently... Oh, that's full mount without the guide. We're currently still at 0.4mm of an offset, so... we shouldn't get any oversqueeze. Any significant oversqueeze. That actually is looking too high up. Let me bump this down by 0.1. Yeah, so this is 1mm of Z-hop now. Also looks slightly foamy though. And I can hear the crackle. Crackle and pops. That's looking a bit wild, that's looking a bit under extruded even, so the first layer may have just been too far down. DSFM sent a tip asking about, say, so first of all, thank you for the tip. Is an optical sensor better than a BioTouch? Depends. Depends. The optical sensors are pretty nice because they're a lot more universal. But both the DC42 optical sensor and the BioTouch are both good bed leveling sensors. But that is looking a lot nicer. But it is under extruding. Oh, because I'm still at 67% extrusion multiplier. Hold on. That's that didn't reset. I thought the printer was reset. Wow, that's also why the offset at 0.4 was too much. Let's just bump this back up to a reasonable number of 95, and that is looking much juicier. That is looking like much better of an extrusion. I'm just gonna see. I'm gonna try and see how well this this recovers and how filled in this is gonna end up looking. And from the side here, can you see me creeping in? Haha. Hi. From the side here, I can see how much extrusion we're getting, basically. But this is looking pretty good at 95. Are you altering the printing settings like extrusion on the fly? Yes, I am. So this is the interface from the Voron, from the Do-It. If I expand it, maybe we can. Yeah. That's the interface from the Do-It. We get live layer time statistics. We don't get a full G-code preview. I guess that could be implemented. Maybe there's a plugin for that. But yeah, we get all the overrides right here. So speed factor is at 100% right now. We can live override both the fans, both the toolhead fan and the cooling fan. And then down here is our extrusion factor of 95%. Yeah, pretty common for any sort of printer host that you can do that. But of course with Do-It that runs directly on the main board. Is this camera lag or does the machine just hiccup every so often? No, that is does the machine hiccup? It shouldn't. So of course it does a Z-hop, which is 1 millimeter just nozzle bouncing up and down. Yeah, that is looking smooth. Yeah. Those stack. Like, one of the things you always have with printers is the layers don't look nicely stacked. These are so nice. Also fat layers, like fat layers always. Very pretty. Okay. So those first 5 millimeters or so, if you want a reference for print quality, like, yeah, that's what he gets. That's what we're gonna see, and we're gonna look at the entire print in a second. Let's just start bumping up speed. 150. Yeah, everyone's saying fast, so of course we're gonna go faster. By the way, spool is already having trouble keeping up. Like this is starting to rotate now. Maybe I should get a different spool mount too. Yeah, I'm just gonna grab I'm gonna grab a floor standing spool mount because I don't like this without the guide. And I'm gonna make sure the ventilation is actually going. Because this is starting to smell. Found the spool mount. How do we do this? Just like that. bit here, and I'm probably gonna run into that at least a couple times. So that's 150. Yeah, so visibly what I can see right now is these back corners right here. These are starting to curl up a bit because we're not removing temperature fast enough. Paul saying, hey, so we're doing 1200 millimeters of travel speed right now. Yes, that is correct. However, we do still have the firmware limits. So the firmware limits still apply to these increased travel speeds. So travel is literally going all out for what the firmware is limited to. So I think right now it's limited to 1500 or 1000. I would need to look at. I think it's at 1000 limited right now. So even as we bump up the speed, all the regular like limiting factors that would keep the machine safe still apply. Okay. So we're getting ever so slightly melty. Layers still look nicely stacked. Extrusion still looks good. Let's bump this up one more. Let's give it another 50% or 50 percentage points, I guess. 200. So flow rate, I don't know how much flow rate we're doing right now, but more. I think we're at around 40 cubic millimeters a second right now. So that is going to be, yeah, that's going to be pretty close to what the Mosquito Magnum Plus is rated at with a single heater. Can we see how much heating power we're using? I don't know. But temperature is rock steady at 260 degrees. Spool mount is giving me some troubles. Kind of hanging up. Why are you hanging up? Oh, because that has the... The spool has like a little slot in the middle. So this is 200% speed. I know it looks slow because the benchy is big, but yeah, there's my hand for scale. We're not in Prusa land anymore. That's for sure. Still looking okay, like you can see the transitions kind of. But the layer stacking is starting to get a bit messy. Let's go one more. Let's go one more. 250. So, I mean, you gotta keep in mind, this is, so the speed factor we're setting here. The speed factor we're setting here because our base speed is 100 millimeters per second. Basically, we're printing at 250 millimeters a second now. Target speed, minus accelerations, all that. So, and all that with a... Did we skip a step? All that with a 1 millimeter nozzle. So, I mean, yeah, we're basically doing 50 cubic millimeters, half a gram per second max. What is the noise? The noise is just the spool getting dragged back in. Because that doesn't, you can just see it back there, that doesn't run all too smoothly. That's that noise. Do it actually shows the speed? Yes, that is correct, and it shows it. It shows it up here. 180. Okay, so 180. That's because it is limited by the minimum layer time. Right. I think we might have lost a step. we might have lost a step on one of the A or B motors because it's slightly shifted. It has slightly shifted towards me. So there's a bigger gap up here and the larger overhang back here. So, oh, and the film is getting stuck here. Why does it sound like the nozzle is rubbing against the pipe? Because it might be. It might actually be, yeah. That filament is kind of sticking up. Because I'm pretty sure it's overheating. It's pretty solid. Maybe let's just get the extrusion multiplier down by a bit more. I'm gonna dump this down to 90%. Just because maybe we have a bit of build-up on the back corner, maybe. Hot in this too cool? Nah, not with that slab of copper that we have. So. Extruder cannot keep up. The extruder can keep up. I'm not hearing any extruder skipping. Yeah, you can see that. You can see that XY skip right there, pretty prominently. But that might just be from a bit of a crashy situation. Now that inside geometry is looking pretty good. It's just the outside has a bit of buildup. Yeah, and it is definitely still over extruded. I don't know why it's over extruding, even though everything should be calibrated. How warm are the motors? Wait, I have a flare. Why am I trying to figure out how warm these are by hand? So, if this camera would boot up. So back here, there's the motor. You can see it glowing. Motor currently is at 42 degrees. That's the stepper motor back here. This other one is at 41. And then the Z-axis motors at the bottom are at 29. And the extruder is at 41. So I guess these are at a very comfortable temperature actually. So 42 is not, I mean, you can feel that they're warm, you can feel that they're heating up, that they're getting a decent amount of current, but it's not bad. And honestly, print quality isn't bad either, except for that one skip step, but we're just going to pretend that didn't happen. And there is, I think, curling and over extrusion from all that, just as a compound effect in the back. I'm going to get the extrusion multiplier down a bit more. I'm going to get it down to 88%. Nah, 87. Let's not do 88. Paul's saying, well, there's no issues with steppers in the 55 degree. Yeah, so steppers typically are rated for 125 degrees, I think. So yeah, with them running at 40, not a problem at all. Yeah, you can see the insides here as I get my fingers smooshed. The insides here are perfectly fine. It's a bit of overshoot on this rear edge right there. But it's not too bad. ABS smell. Yeah, I still can't get over how neatly those layers are stacked. Because that is that's always something that's bothering me about, well, I guess, small layer heights. But especially layers that aren't, even at regular layer heights, like 0.15 or 0.2, where you can see that the layers aren't perfectly on top of each other and where the layer height is slightly different, that bothers me. But here, of course, with the large nozzle, you can't really see anything about that. Few strings, but that's not unexpected. Time to pull out the N95. I don't think the N95 is going to do much. Yeah, so Golden Jagger is saying, hey, use input shaper. Input shaper, pressure advance, all those like extra high-end software features, those are something to be calibrated and to be set up in the future. So that's not something I'm gonna set up today or within the next couple of weeks probably, but it is something I'm definitely planning on setting up for this printer eventually, because if there is a printer that kind of can handle those or can make use of the benefits that those advanced features give you, like probably the Voron is it. Sam is asking what nozzle is that? So it's a Mosquito, a Slice Engineering Mosquito Magnum Plus hot end with a 1mm Bridgemaster nozzle. So it's a chonker. Like it's quite a bit. It's quite a bit of heater length in that entire setup. So what you're seeing from the heater block is not just. It's not all. It goes up about another 2 centimeters worth of copper that directly touches the filament. So you don't have any brass in between, you don't have any stainless in between. It is literally the copper heater block directly contacting the filament. So that is like your maximum. Well, there are still ways that you could improve heat transfer, but pretty much for what we have today, that is pretty much the maximum heat transfer into the filament we could get today. I think it's time to bump up the speed again. I'm getting bored. 300. And minimum layer times don't seem to be that much of a problem. So requested speeds, I'm seeing 800, I'm seeing right now 70, back to 100, and yeah, as expected, the limiting factor is the minimum layer speed that was set up. I guess we could try again without a minimum layer speed, and just see how fast that hoons through the print. Would you prefer a Mosquito over a Dragon HF? I've not used the Dragon hot ends, but I know that a lot of people like them, specifically in the Voron. Beds wobbly? Nah, so you might see things shaking around a bit, but that is simply because this printer is standing on rubber, what they're calling compressor feet. So you look down here, that is the rubber feet that the printer is sitting on, and you can see that kind of moving around, and also the table slightly shaking. But those feet are ever so slightly elastic, and the dynamic forces that we're seeing from the printhead, those are enough to shake the entire printer frame around a bit. Try a 10-minute bench. I can't. I can't without tuning. Why are you showing? Why are you saying 100? What's up? What's wrong with you? Hello? Did that reset somehow? 290? 300? Huh. That looks better. So I think one thing that could become an issue, though I don't know what the limits are set for that, is retraction speed, because by default it's 40 millimeters a second, and Yeah. That I don't know if this extruder can do like a 200 millimeter per second retract. M220 S1000, no, we're not going to 1000% or to 10x speed, I guess then. What is the print speed now? Anywhere between 170 and 100, roughly. Though most of the geometry right now is acceleration limited. So at this point I can bump the speed up as much as I want to, and it's not actually going to move the tool head faster, because it's simply that there is some delay for the tool head to get up to that speed. We're still slightly over-extruding though, aren't we? That bow line looks intentional? It is not, I can tell you that much. The belt seam near the feet went loose when he did that? What? Oh, the gearing belt? Okay, nothing I can do about that because there's no way to tension that. Huh. Okay, I think we should, so, first of all... Yeah, actually, you know what, Franicek? Let's do M220 S1000. So that is 10x speed of what we originally had. I just want to see it fail. Because right now it's just like, well, it's fine, right? So we do need to bump up accelerations to get any more speed out of this. And I'm gonna quickly look up the G-code for that. Set accelerations. We are at 6,000 and Z 4,000. So if I bump up the acceleration to... Let's just do 9,001. And then Z, I think, is fine. Let's give it 50% more acceleration as well. So now that should effectively go... Yeah, you can... Wow, you can see the difference quite a lot. That's going quite a bit faster. You know what? Let's go 12,000. Because why not? You only do a first print once, right? Yitpo, I guess. So that's 12,000 acceleration on X and Y. That Z-hop is brutal, by the way, with just 4,000 millimeters per second squared. I think accelerations could go, maybe could go a bit higher, because when I first tuned this in, 2 days ago, I think I thought I hit the limit, but since then I did increase the motor current just a bit, and maybe the machine is broken and is now a bit smoother. I don't know. Let's do 15K. 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 Let's do 15K. Because why not? Why not? Thank you for the 25K, Pedro. Yeah, It's a speed demon. It is crazy. So I've tried other printers. I've tried having them go this fast, but there were some printers. One comes to mind from a while back. It was like tall acrylic frame that claimed it was able to go this fast, but it was just absolutely failing at it. They were saying, "Oh, it's like super optimized for this," but it was garbage. This, on the other hand, it's not even breaking a sweat. Like those Z-hops, like holy crap! You blink and it's gone. 3DP, this is ASA. This is not PC blend. This is Pusherman ASA natural. Somebody said it can do 20k accelerations. Let's do 20k then. 20. Okay, actually I'm gonna do over. Well, I'm gonna do over 20k of acceleration X and Y. And if we get a horrible skip step noise in a second, well, that's that. We're sent. We're at 20k accelerations in X and Y. You know what? The thing slowing it down the most right now, as far as like effective print speed goes, I think, is actually retractions. Because it pauses for a second, and that is when it does the retraction. Then it does the Z-hop. So, yeah. What happened up there? Something that went wrong. Like right there? Looks a bit melty. I don't know what happened there. Print a vase? I guess we can do a vase. But first we can do an M220S 1200. So this is at 12x the original speed, of course, acceleration limited, 20k accelerations. Yeah. I mean, with the tool just jumping around like that, I think the enclosure makes a lot more sense now, because it's not an enclosure for actually keeping the heat in. It is an enclosure for keeping your fingers safe, because if you get your fingers in here, I think just from the inertia that could break a bone. Not even kidding here. If this thing spools up to... Belts are too loose? Possibly, I don't know. If this thing spools up to full speed and catches your finger, like that finger is not going to be happy. My belts are too loose. Let me see. Nah, I mean, I could tension the belts to a point where they're like rigid, but look at that. I guess they could use a bit more tension. They do loosen up after a bit when you just use them. So I did tension it up to a level I was comfortable with when I first set them up. Yeah, Z belts for sure. Those are tight enough. But XY, you can actually hear the XY belts slapping around. That's that slappy noise. What's back here? Oh, that's the tape that I used. Still acceleration limited though. Yeah, I think if we just entirely cut out any sort of retracts, we would get less stringing because it would just accelerate across. and it would speed up the print so much. Yeah, but at this point, with the overhang right here, I should not stick my finger in there. With the overhang up there, you can kind of see that, yeah, it is starting to get a bit melty, but I guess by the time the hot end makes one round, it's good again. Powder retractions you could change or disable that on the fly. Yes, that is correct. I could enable that. And we're going to do a pressure advance tune? Yes, but not today. Not right now, not today. A sticker with the gears on the crushed hand, yeah, that warning sticker. So what was our print time so far? Where's my status page? Job duration, there we are. So far 33 minutes worth of printing for a Benchy at 1.5x scale. This doesn't look too bad. I mean, yeah, it does look rough. Especially now, oh yeah, whoa. Yeah, this is looking very rough now because now it's just a melty mess. This is not getting cooled enough. But the layers are still nicely stacked, so yeah. And again, for speed, this is still a 150 scale Benchy, so yeah. Bridging is horrible. Yes, part-time Ronin, you're 100% correct. Bridging was not tuned in. Bridging was not set up, configured, taken into account. Oh, actually now we're bridging. No, bridging isn't that bad. Actual bridging across the top here? It's not that bad for not being tuned in at all. Look at that speed. Look at that Benchy go. It's exploring the world. Okay. The pause print, cancel print. Well, wasn't that inevitable? Let me give you a quick walk around of this first print. Of this first, not very pretty, but quickly printed Benchy. So down here, default speed. Actually, so size-wise, like there's my hand. This is bigger than a regular Benchy, obviously. I can grab a regular one if I find one. There's your regular Benchy. There's the one we just printed at 150% scale. So that is, I mean, it's a lot more material, right? But yeah. Hold on. So what I noticed was it was still slightly over extruded. You can see that top surface, still a bit too much material. Up front here, no, up front here, maybe a couple more solid layers. That would have been nice. Overall, not too bad. Yeah, that's a cooling issue right there. We did have the skipped step. So this is the back side. That's the side that I was seeing. Skip step, that was causing some real issues right there. Front side though, is not too bad. So the layers, even at, so this is at like full blast, full bore. The layers are still nicely stacked, and that's something that I do like. Like right there, you can see at the bow right there. That is still a nice stack up of layers. Then the cabin's okay. There is a bit of overswing on this side, but not too much actually for the speeds that we were going at. Then the little tray in the back, That is actually a calibration cube built right into a benchy, by the way. So this is supposed to be, I guess at this scale, 15 millimeters if you want that as a calibration cube. Doesn't look too shabby. It does not. Obviously, it's not the nicest printing. Here we go again. Me trying to call it a printy. This is not the nicest benchy that I've ever printed, but for 35 minutes worth of print time and for no tuning, first print out of the printer, it's not too bad. Nero wanted to see weight. So let me grab the weight. 33.58 grams. So that is, yeah, that's pretty much 1 gram per minute. That is 1 gram per minute that we squeezed out, even with the limitations of layer times, etc. 33.58. 1 gram per minute. Crazy. Somebody said, like, on Twitter, somebody asked, like, do you really mean 1 gram per minute? And I was like, yeah, last I checked 1,000 or 100 cubic millimeters are still 1 cubic centimeter. Yeah, 1 gram. Wow. Wow. That's gonna cost so much in filament, just trying to run that. Alright, should we do a vase? We should do a vase, I think. Just for shits and giggles. So, ABS smell is getting pretty bad in here. So we're gonna do a vase and then I'm gonna call it because this is gonna mess up my throat for the next 2 days. Print settings. Where's that? Spiral vase? Yep. So I'm not gonna save that. I don't think we can print a benchy as a vase. Let's see, I did have a spiral vase somewhere. A vase in ABS is going to be a bit tricky though. I had that in downloads, right? Vase, but that's not a vase. Abstract vase. What's the difference between you two? I guess it's just the same file. So our print profile was a bit slow. You can add a cylinder push slide. Oh yeah. Our print speed was a bit slow. So 100 was not nearly enough. So let's do. I mean, we're going to be limited by extrusion volume per second. We're going to be limited by that anyway. So 300 should be okay. And we still have the high minimum layer time. We still have the high acceleration set. That should speed things up, right? Yeah. So basically for this vase, it's 16 minutes. For vase 125 millimeters tall. Yeah. So I'm getting tips that I should increase the extrusion width. Let's go to 1.3 then. Though honestly, do 2 millimeters now. That's too much. I'm gonna stick with 1.2. No, I'm sure that is correct. And we can lower the speed should we need to. This is basically all in the 50 millimeters a second range, so. Yeah. Larger layer heights, nope. We're seriously gonna run into flow rate limits. So that's already pretty high. As far as I'm concerned. 16 minutes for a vase. Let's see, are we still warm? Yes. I think Prusa slicer does support the export to. It does support export to Octoprint. I don't know if it supports export to RepRap firmware. But this isn't too bad. Abstract vase 1. Set multiplier back to 95. Well, that would increase the extrusion width as well. It's basically the same thing. I'm gonna leave it at 85. I'm gonna leave it at 85, but I will reset the speed factor back to 100 because that's crazy. You can't stack any more on top of that. That would literally just be running into the speed limit of 1200 or 1000 millimeters a second as far as linear speed goes. And also, I do not know if this is going to be an issue with the part peeling from the bed, but I guess we're just going to find out. Let me move you over here just a bit so the wires don't get caught. 260 seems a bit warm for ASA. Well, the Prusa box actually says 250 to 270, and the spool itself says 260, so I think 260 is just fine. But also, like, again, it really depends on your exact printer. What temperatures are okay and which are not. Why no test cube? Because I'm not printing calibration cubes. So that is way too high. That's better. Okay, baby stepping is at 0.1. I'm just gonna quickly restart that print to make sure all those layers are at the correct height. I don't want to risk having this vase come loose, though. That's pretty well stuck. There we go. So you go over here, print again. Measure it, measure what? Measure the thickness? I'm just going by like what looks good. Yeah, I know I missed the blob. I got it. Those belts need some... Can I live tension these? I think I can, right? If I can find the... There it is. Oh yeah. That could use just a bit of tensioning. Come on. Yeah. Yeah, that's better. And then same over here. Oh, this one's actually a bit better already. Live tensioning will cause layer shift. Yeah, I know. We're still just on the first layer. It doesn't matter. On the infill of the first layer, even so. That is not going to be a problem. That is not nearly enough. Well, I don't want to rip stuff out. Just because someone in chat said I should. Yeah, now we're cooking. Filament getting stuck. The belts can take it. Well, the thing is, I don't know if the belt clamps can take it. $1 spool holder. No, the spool holder was actually it's actually like $6, not just $1. But yeah, like I said before, so that's the stock spool holder, and it would pull off the spool sideways. But if you build the Voron fully and not just the base setup with the printed forward parts that I'm doing right now, you would have a separate inlet right here that has a nice guide towards the spool mount, and then a nice Teflon reverse button to the tool head. So that would be a better setup. But it's just, you know, I'm just making things work right now. You know what? There we go. Just turning off the noise reduction for a bit, because you probably can't really hear the printer noises all too well. There is a bit of fan noise going on, but whoa. I just want you guys to hear the whole thing. Someone pulled something off. Leaky vase. Yeah, so full 300 millimeters a second was a bit too fast, maybe. So this is at 74% right now. That is still too fast. The problem is not, you know, the hot end not being able to supply enough material. It is the ASA being not being able to cool down fast enough. So the way you could kind of work around that is by actually putting a big fan in front of your printer and just having a constant airstream going over it. Yeah, this is still super wavy. I mean, I guess I could also lower the print temperature by a bit and drop it down to 250. So right now we're at 250 hot end. That's cooling down right now, and at 50% speed, which is still 150 millimeters per second, theoretically, even though it's saying 82. Why are you limited to 82? Why are you limited to 82? Okay, but that is starting to shape up. There's still a bit of curl. Yeah, the filament is still... Actually, you know what? Let's use the power of the thermal camera again. And yeah, thermal camera would be a nice option if you actually want to tune in cooling for your printer. So if I point you over here, so there we go, that's what you want to see. That is not really cooling down all that much. That's still 100 and something degrees when it comes around the second time. the calibration, that's why it's lagging a bit. Yeah, you can even... shouldn't push it in that far. So you can even see the freshly laid down line in like hot white as it's getting deposited. This is hard to coordinate. But yeah, that would indicate that you need a bit more cooling, a bit more airflow, you know, over your part, or just drop down the hot end temperature if that's suitable for your material. But yeah, still a good amount of curling, though honestly it kind of looks artistic at this point. I'm gonna bump down temperature to 245 one more time. Try blowing at it, yeah, I guess that would be an option. Yeah, it's still a temperature issue. This is still, I mean, it's looking a lot better than it did at the start, obviously, but yeah, those folds at the front here, like those right there. Oh yeah, I can feel it. It's still soft. It's still dented. Those back here. That's all temperature. And I guess having a sock on the hot end would help as well. There is a, I guess you can just barely see it. There is a heat shield on the nozzle. But that is mostly to shield the nozzle from the airflow of the fans. So it does do a bit. It does shield your print as well. It doesn't really have a... So running the fan at low speed, no, the fan is at full blast. We were never using PTG. That's the part cooling fan. We were never using PTG at low fan speeds. It was always 100%. Yeah, this was not calibrated for temperature yet. Literally first prints today, live on camera, uncut. So what you're seeing, I'm seeing lots of curliness still. So we're at 235 degrees, which is I think about as low as I want to go for ASA. I'm gonna drop it down another 20% speed-wise. So now we're at 64 millimeters per second, which is still a decent amount of material flow, but yeah, obviously when cooling is the limiting factor, then there's not much you can do there. The Benchy was at 15.7 cubic millimeters a second. Well, we did weigh it, and in the end it was 1 gram per second. So that's about 90 cubic millimeters per second. So, I mean, not exactly V6 speeds, right? So Benchy at 30 something, 35 grams, printed in 35 minutes. Oh, one gram per minute. Hold on, 1 gram per minute. Sorry. The hot end should be able to do 1 gram per second, so. Right. It's still too hot. It is still too melty. Are we getting... Just trying to see how much airflow we're getting, and I'm not sure this little fan is actually delivering all that much. Because right now it is still very, very melty. If we pause, Yeah, there's a good amount of airflow coming out, but it's warm. It is warm air coming out of this. Huh. Yeah, bigger part fan. Probably a good idea for printing stuff that actually needs it. Now, in real life printing with real life parts, you're probably not going to have that much of an issue. You know, especially once parts are a bit bigger than, you know, the fine details on a benchy or just a single vase wall. It does look good, it's just that it's too melty. Now one thing I will probably also do is just to verify the temperature we're getting on the hot end itself. It does have the extra thermistor hole, so the Mosquito Magnum Plus has 2 thermistor holes and 2 heater cartridge holes, mounting points, I guess. And I think I should, or I can do that right now, actually. I was gonna say I would use a... Ooh, but that's a heat shrink, and that is too big, unfortunately. I do have a Type K thermocouple attachment for my multimeter. Yeah, I guess I can stick that in there at some point. But what I was gonna say is I might end up adding a second thermistor to the hot end and just hooking that up to a different printer and seeing like what that reads. You know, a known good thermistor with a firmware that I know is set up for that thermistor correctly, for the thermistor, not a firmistor, and just reading back what that second thermistor is reading, because I'm not sure that the thermistor table is actually correct for the standard 300 degree thermistor in this hot end. I believe it's a 300 degree one, because so far it looks like the temperature is actually much higher than what I think it is. So that might also explain some of the melty and temperature issues we were seeing. But yeah, at 42% speed, down from 300, well, we're effectively printing at 51. So 50 millimeters a second effective speed, not the speed you set in the slicer, but the speed you actually get. And at 220 degrees right now, which does seem rather low, it is looking a lot nicer. These layers are looking nicely stacked and not melty at this point. Anyway, I'm going to try 205 degrees, which I would assume would be too low. Also, PAD tuning overshoot, not that much actually. If you look at the temperature graph, that is pretty much bang on. There is like almost no overshoot. So that's auto-tuned by Do-It, and so far that auto-tune setup has been working out perfectly. Yeah, so it's at 205 right now, and it is looking just about perfect. So yeah, that thermistor table must be pretty far off. No wonder I'm getting a coarse throat right now. Wonder how hot the thing actually was. Unfortunately, I can't just point the FLIR at it because it's a reflective surface, and as soon as you have a reflective surface, like, you can't really take a temperature measurement off of it. Should have printed a giant vase, yeah. So I'm at 195 right now. I guess that would also explain why the PTG was doing so horribly. Okay, 160. Because it's still looking melty in the back. How hot were we printing even? Oh, okay, now we're getting some clicking. Just dropped it to 190. Now it's clicking, okay. So I don't know how far it actually was off, but yeah. And yeah, it's already getting melty again. It's already kind of having curly issues. Huh, interesting. Yeah, you can see back here it's active. No Google. Back here it is like actively pulling in. Interesting. Holes in the wall, yeah, those holes in the wall were because I dropped the temperature to 160 degrees and that was too low. Kamaz, the stock Voron, if there even is such a thing as a stock Voron, can use anything you want basically. So I checked the CAD files recently and there are stock mounts for a V6 style mount and a Mosquito style mount included. So those are, I guess, are the two stock options, more or less. Yeah, V6 as in anything that fits in that V6 mounting size and mounting pattern. Is the nozzle low? What do you mean is the nozzle low? Now the layers, so what's happening right now is these bits right here, they're physically curling up. So because it's too hot and the layers below it aren't supporting it enough, it's physically curling up. Yeah. 98.3, I'm gonna cancel this right now because this isn't really going anywhere. But if we zoom into like that center bit, actually that's stuck down pretty well. that bed adhesion is pretty good against the glue stick. I know that much. How close are my fingers to 230 volts? Probably too close for comfort. You know, we can flex that bed. Yeah, I'm just trying to get it to cool off because it's still burning my fingers if I touch the bed, right? It was at 100 degrees just a minute ago. Yeah, for the ASA, we don't really need any glue stick on top. But because we were printing PTG a second ago, Chad told me I should not print it directly onto PEI, so I didn't. Now Chad is telling me, hey, you can print directly onto PEI. Like, come on, have an opinion. So I'm gonna show you that, like that. No. That part is pretty. That part is nice. Okay, but aside from the overheating artifacts all throughout the print, that part printed pretty nicely. Right. And we're gonna stop you and get you to cool off. So that basically is the Voron 2.4 build. We've got two parts printed. We've got the bench at 150% scale, almost printed, and we've got the abstract vase. And there is potential here. There is definitely potential here. Again, I keep pointing out how nicely the layers are stacked up. And typically, if you hold the layers against light, like I have my key light right there, you can kind of see like slight deviations where X, Y is slightly off or the layer height wasn't correct. And there is nothing of that here. So there is literally no deviation in how neatly the layers are stacked. And that is basically what you're trying to fight with every other printer. That is fantastic. So what will this printer still need? Tuning, obviously. So it's going to need some tuning for materials. It's going to need some tuning for cooling in particular in this case. Like, I don't know how much cooling we are getting. I'm going to have to try out a couple different materials. I'm going to try some PLA. I'm going to try some PETG. It hopefully is dry this time. I'm going to try some actual ABS and not ASA. Polycarbonate blend. This printer will also need all the paneling done, and that is a whole bunch of... No, Franciscas, it does not need clipper. The firmware is literally the least issue right now, okay? Come on. Yeah. I'm going to need to print some extra parts. I'm going to need to print the panel mounts for this, the filter mount, all the parts that make this a full Voron, all the skirting in the bottom as well, obviously too. And thank you for the tip, Christoph, but there is not going to be another Voron stream because tuning and setting up and trying to figure things out, I don't think is something where I want to have chat watching or have you chat kind of trying to interfere, trying to tell me to use clipper. And yeah, that's my Voron build. Okay, thank you all for watching. Thank you all for stopping by. Bye. No, I'm not going to put clipper on this, okay?